Caroline, what is this, Lady Ada?
Hi, everybody, and welcome to Show and Tell, the most fun you can have on the internet. It's me, Lady Ada, with me, Sister Lady Ada, and special guest, engineer Tony DeCola.
Hey, how's
visiting
it going?
here from Adafruit West Coast, but
Not
now
a hologram.
in the flesh.
Yep, real
Exactly.
Tony.
I'm not a robot, despite all of the blinking things on me.
And we're here at Adafruit headquarters. We're going to do our show and tell. This is a time when you, the maker, the creator, the dreamer of dreams, shows up and tells us what you're working on. Shows it off. Even if it's working or it's not working, we'd love to see it. We'll be here until 7:50. And kick it off with some Adafruit folks, and then Orlando and whoever else comes in. So start off with Noah and Pedro.
Howdy, everybody. How's everybody doing tonight? So we've been learning a lot about EagleCAD and learning how to design simple PCBs. So this week's project was just a kind of quick look at how to make single-sided PCBs using an other mill, CNC. They're now called Bantam tools, but I'm calling them other mill, formerly known as other mill. So what I'm playing with is double-sided PCBs. So I put together this sort of feather wing, and you can kind of see that I am in the need of some finishing techniques. So this is something I mailed about a week ago, and it's starting to oxidize. So it kind of looks rusty. So there's some interesting techniques that you can do to kind of combat this from happening, and we'll be kind of showcasing that in a future project. But I thought I'd kind of show you guys just kind of the progress of learning, making a double-sided PCB. The main thing about doing this on a CNC mill is just getting correct alignment. So there's like an alignment bracket, and there's some nifty stuff you can do in software to make that work so well.
It looks really aligned though. The holes are like right in the center.
They are pretty good. The Bantam Tools machine does a pretty good job of lining them up when you set the alignment bracket correctly. And there's some new tools and jigs and stuff like that to make that even better. So we'll see how that pans out. But that is sort of this week's project, just a kind of quick look at the process of getting your EagleCAD file into OtherPlan and milling it out on a single-sided board. So double-sided coming next weeks.
All right.
Can't wait.
Pedro, did you want something?
No. House is full now.
Oh, okay. House is full. We'll be back.
All right. Hello, Colin.
Hello. How are you guys doing?
Very good.
Good. Excellent. I was just going to stop in and say hi and just show you that I updated the Mohs Resistance game that we have, which is the resistor color code game for iOS. A little blown out there. But I went back into Unity, which we made the game in, and I updated it for 64-bit CPU architectures, and it works in iOS 11. And if you've never used Unity, I don't know if anybody ever used Unity, it's like a weird combination of scripting and C# and like a GUI to make games. But I was going to show you real quick. Thought it might be kind of fun to share my screen.
And Mohs Resistance, for the folks that haven't heard of it, we made a video game of doing resistor values. It's a real thing. It's been around for a while.
Right. You'll see how it works in just a second. So, you know, it's like basically in Unity, you can arrange a scene with stuff. This is the 2D view, and if I explode it out to the 3D view, you can see that it's actually, that's like the title screen. It's actually, you know, elements arranged in space. Because Unity is by nature rooted in 3D game design, so the 2D is kind of like an add-on feature. So yeah, if I go into like the main game, what's that?
Vermal's back.
Vermal? I didn't even see it.
Never went away.
Never, always in my heart. So yeah, so there's like the basic game view in the quest. You can see multiple buttons are visible here together right now because I have it by default. And if you look in the actual game, when he falls, because he falls down into a circuit board while you play, he actually does fall down a long ways. It's not like a, you know, just something done, you know, as a little trick in code. It actually does move down through space and falls into the circuit board at the end. Hopefully with the correct value set, or else we release the blue smoke monster. So yeah, it's just kind of fun to look around and see. I'll also show you the
That's cool.
level select screen. Yeah,
I've never seen Unity. It's totally different, but
yeah, it's a lot of like you select an object in the view, in the main, you know, view here, and then there is over here like the stack of scripts that are attached to it. So none of them here have my custom scripts, but yeah, you can see, and then you write in the code, you write little your variables. You can specify them as fields that they can fill in from the GUI. So you can drag something from here into one of these fields, And so you can set things from the graphical interface. It's pretty fun. It's really great. And that's pretty much what I've been up to.
All right.
Nice, sweet.
Available down the App Store, and we're looking at Android.
Yes, looking into it now.
Yep. All right.
Thanks, Collin.
Next
Thank
up,
you.
Scott. Hello, Scott.
Hello, can you hear me? I know I'm kind of far from my mic.
It's not great.
First, I wanted to say thank you to everybody I met this weekend at World Maker Faire. It was super cool. And the previous weekend at Seattle Mini Maker Faire. That was also super cool. Sophy is one of those people. She'll be up later. And I wanted to say, if anybody's going to Open Hardware Summit, please get on the Discord. We have a channel for it, and I'd love to meet up with you as well. I'm going to order some stuff to give away. If you have a preference, let me know. I haven't made the order yet. The other thing, I ran off at the start because I remembered I hadn't showed this yet. So this is the front control panel of my toaster oven that's in pieces. And it's actually, there's nothing behind it. But I've been reverse engineering the PCB for it. So there's like little clicky button. Oh, those are LEDs. There's buttons here. There's a light up LCD display. And this is one of 2 circuit boards in the toaster oven. The other one does all the like power stuff. So I'm hoping to replace this alone so I can have a CircuitPython powered reflow toaster oven. And I will follow up more once I get more done.
That's
right.
cool.
Amazing.
Okay, next up, we're going to Erin. Hello, Erin.
And
Hello. So my project this week is pretty silly. It's a lot of fun. I do LED light dance shows for like corporate parties and stuff like that, and I had to do a Star Trek themed costume for some dancers from some Stiltwalkers last week, and I ended up making a wig that with a circuit playground that's just, it's sort of awesome. So I'm gonna just go ahead and pull it on here. So it has a lot of color modes, but my favorite is the sound reactive mode. It has light pipe tendrils sticking off, which are very kind of Star Trek 1960s beehive wig. I don't know. It's a lot of fun. Everybody seems to love it. And I just can't stop wearing it and making noise. It's a lot of fun.
looks great.
Yeah, it's very silly. I have another one here that shows kind of, this one's inside out. It's got just the circuit playground on there with a little battery extension cable with a switch on it. And then it's got the light pipe actually secured directly to the face of the board. I sort of melted it on there and then used some crazy glue to attach it. I'm doing a tutorial in the Learning Center about how I did it, and it's really actually super stable. And I actually pulled one off and I broke the LED, so it's really strong. It's staying put. So it's kind of cool. I don't know. It's a very weird, silly project. I don't know, but I'm having fun.
Very cool.
I think it's wonderful.
Good stuff.
It's
Next
wiggy whack.
Where is Orlando? Is here? There he is.
Yeah.
Hey, Orlando, how's it going?
Yeah.
Hello there. So I'm actually going to share my screen real quick. Can you guys hear me now?
Yep.
Okay, cool. So a couple weeks ago, this part has been out for a while, but I had this Biomed shield. So basically, it's a shield that has a ton of like biological sensors. One for heart rate, one for things like EKG, EOG. And I showed this off a while back, and they actually got pretty popular. So what I want to do is actually modify this a bit because I actually want to try to sell it. But at the moment, it's kind of like it would be way too expensive. So in doing so, I kind of developed we wanted to put a little light sensor on it, a light sensor and a UV sensor. So this is what we have here. So it's a little breakout board, the little small thing here for the APDS ambient light and UV sensor. And so it has, I like it because it combines both light and UV, which are ones I could find otherwise didn't have both, and it's relatively inexpensive. So I kind of made this little portable UV ambient light sensor where they hooked it up to a micro view and was able to demonstrate light on, lights off at different intensities. And actually, one of my students, he kind of championed the development of the little board, and he actually showed the interrupt function. So if you look at this video, as the light, as the light turns off, turns on, so that's like showing the interrupt function, which he programmed in. So it's just a little light sensor we've been playing around with because I want to put it on this Biomed shield eventually. So yeah, that's kind of what I've been working on recently.
Very cool.
Reducing BOM costs is like that's the key, right? That's what engineering is.
Yeah. Otherwise, the previous one was like $100 bill of materials. It was kind of insane. So
Okay.
We should come up with a badge for that.
What, engineering
Cost
cost?
saver.
Yeah, it's like it'll be a badge that's like a spreadsheet, and you get to tear the badge in half. Yeah.
Reduce the cost.
Yeah.
All right. Well, thanks for the update.
well, thank you.
Good luck.
Next up, Matt. Hey, Matt.
Hey, Pie Glass.
Hey guys, I wanted to demo a couple of things that I couldn't show people at the Maker Faire because I was having bandwidth issues. One of them, well, is the new picture program. Takes pictures at 5 megapixel pictures. I achieved this by making a sub-process call to the Raspberry Still program, and I was actually able to pass it my zoom values. I had to parse them, and then it passes it as the ROI, so I could take zoomed-in pictures. So when I zoom in and take a picture, it quits my program and runs the still program, and then quits and goes back. And then, so let me close that. Then the YouTube, the way I tried like a half a dozen ways to get YouTube to work on the Pi Zero, and none of them like run actually on the Pi itself. The way I figured out how to do it was a free Android app called Raspberry Still, and you go to YouTube, you hit share, and then as Raspberry Cast comes up as an option, and you hit it, and within a few seconds, it will start playing your video and audio.
That's cool.
In full HD. And then I just wanted to show you, do a little screen share and show you guys the picture I just took. So I just took this. This is the zoomed in picture. You can see the quality is pretty good.
Yeah.
Wow.
Let me start one more. I'll show that some other time. Then at the Maker Faire, I took some pictures with the my glasses, and the coolest one I took is this one here.
Oh yeah.
Yeah, it was great meeting you at Maker
That
Faire.
handshake.
Yeah.
And then I met someone in the Discord chat, Pyrus Productions, and they helped me make a logo.
Oh, wow.
That's a great logo.
That works.
Nice.
All right, Matt. Nicely
All right,
done.
it was nice meeting you.
Yep, thanks.
All right.
Great photo.
Next up, Azure. Hello, Azure. Unmute your mic
Hello.
and show us your project. Oh, Azure, your microphone is not on.
That one. There we go.
It's on.
Yeah.
I had 2 mutes. Okay, so I know I've showed it off before. I have the big blue cat head. He's not on my desk right now. One of the issues with doing costuming like that is it gets really hot really fast. So I have a head fan inside of it, as well as I made a box out of Legos with 2 sets of fans inside of it that are incredibly strong, and you can feel it from almost 10 feet away after I hold it there long enough. And I'm showing it off tonight just quick because I have a much better version and a lot cooler version. I know Noah and Pedro, I showed them a picture of it this morning, and they seem to like that a lot. And I'm hoping to have that about a month from now. But yeah, that's pretty much it.
Okay.
Okay.
That's great.
Cool costume.
Thermal cooling.
At Portland Comic Con, I saw a company that actually makes like fans to put in helmets for like cosplayers.
Yeah.
So that's kind of cool. You can turn it into product.
Yeah, we're approaching a world where the costumers are now able to get all the electronics to make this all work. So this combination of the two. And what was it? What's the name of the, not Embedded, it was the name of the magazine that Circuit Python's featured in.
Oh, it was IEEE.
IEEE.
Yeah.
It was like Spectrum magazine or something.
Yeah,
like that.
IEEE Spectrum.
And they noted that this is great because you can build a full costume and then you can just plug it in. It shows up as a USB drive and you can modify stuff. You don't have to worry about kind of putting all the things in and reaching in to try to reprogram it. So that's cool. Okay. Next up, Adam.
Hello.
Hello there.
Hey, welcome back.
Yeah, so I had a ton of fun at Maker Faire meeting everybody in the Discord. The Discord meetups were a lot of fun and also got some cool stuff to put under the SEM. So thank you, Lamore and Phil. I don't know what this was, but it's broken now, so it'll be really easy to put in the SEM. It's some sort of wafer.
Mistakes were made.
Mistakes were made, yeah. So I got that, and then I got a cool little baggie of all of these small things. And all these small things is a lot of really cool stuff to put into the SEM. Some of it's going to need to be decapped, so I'm going to have to figure out how to get fuming nitric acid here and also how to handle it. Well, I know how to handle it safely. I just need to get these stuff here to handle it safely, because if you try to like filter it out or anything, like people have done this before where they try to filter the fumes from fuming nitric acid and basically made dynamite in their filter. So got to avoid all that sort of crazy, stupid stuff. There's a lot of cool samples to put under the SEM, but that's going to take a little bit of work, and I will show you why real quick. Let's see, share screens. So this is right before I left. The SEM's filament burnt out again. As you can see here, another little hole in the filament, which is no good. It means no electrons are coming off this anytime soon. So I started doing some investigating, and it turns out I've got a little bit of a leak rate going on. And that leak rate, so this is a graph of pressure, or of the chamber pressure on the SEM. And you can see it pumps down really quickly, it closes the valve off, and then it starts climbing back up again. So got an issue there, got to figure out where that is. So I started taking things apart, and that is rust, or something similar to rust on the high vacuum side of the SEM. And this is actually an O-ring that has motion in it. So this is what, I mean, this is a motion seal on here, and it's this contaminated and this dirty. It's a really bad sign for vacuum. So I'm working on replacing that right now. This was the last image I took right before it failed. So like, it was literally like, you could see where it stopped on this image. So that was kind of unfortunate, but I think I know how I need to proceed. And once I do, hopefully I will be left with a working SEM to put all of these very, very cool samples in from you guys. So it's really exciting. And thank you very much.
It was fantastic hanging out with you.
What?
It was fantastic hanging out with you, not only on digitally like we normally do, but in person.
Yeah, no, that was a lot of fun. Thank you.
Yeah. All right. Next up, Sophie. Hello, Sophie.
Hey, Soph. Can't hear you yet.
Oh, hi. Can you hear me now?
Yeah.
Hi. So, and this is a project that I built with my husband. He did it's our first Raspberry Pi project, so he did the programming and the code and stuff, and I designed it and built it, and then we sort of collaborated together on the like the behaviors and the faces and all the sounds. Other than the HAL 9000 sound bites, the sounds are, oh my gosh, my cat, no!
It's like a circus there. Wait, now I can't hear you. Your cat turned off your mic.
Yeah.
Okay, sorry about that.
That was awesome.
So anyway, it giggles when you shake it, and when you pick it up, if it's idle, it sort of wakes up, does a little like thing. If you put it on its back, it goes to sleep. I don't know if you can see it kind of sleeping.
That's nice.
Sort of snoozes, and then if you press the button, the only button on it, press the button, it goes into like a selfie mode. And then the idea is you just hold it out like that, and you smile, and you press the button. And it turns.
Look how it's just freaking out.
And then you have your photo. So it does like several different sounds. It sort of randomizes it. Sometimes it does like a dot matrix printer impression, and sometimes it sounds like it's squeezing the print out. And you know, it's just like sort of, it's a pretty simple project, but we added like personality to it just to kind of make it fun. And then the back we left clear so you can see all of the parts inside. So that's the Pi. We put a fan in there. The screen is directly behind the Pi. That's the thermal printer. There's some proto boards. And then there's an accelerometer and an amp at the bottom for the speaker. And I basically designed it so that if anything were to break at Seattle Mini Maker Faire, we could get into it really quick. So all of the hardware is available in the back portion. You just pop this panel off and you can fix anything you need to fix. And then I also mounted the handles. The handles are 3D printed, and I mounted those to the middle panel, which is the same panel that all of the hardware is mounted to. So the weight is really solid in your hands when you pick it up, so you can shake it, and it's just... Sometimes it makes a joke about self-destructing. And yeah, to get a better idea of what's going on inside, this is one of our prototypes. So you can see it's three acrylic panels. And then when we were prototyping it, we just laser cut cardboard to build up the sides. But for the final, it's laser cut ply. And it's just glued together and filled and sanded and painted. And then the front panel is back painted acrylic, which is just a really nice, like, clean application of paint. I think I was hanging out in.
I'm sorry, Dave. I'm afraid I can't do that.
I think I was hanging out in Discord when I was painting it. So thanks to whoever was hanging out with me while I was waiting for my paint to dry.
Yeah, I love the blocky. I mean, it's acrylic. It's shiny, but it's got this really clean line, kind of abstract look. I like it.
It's the like color scheme is good too.
Yeah, it's like a Hitchhiker gets Guide to the Galaxy or something. It's like it's perfectly alive and it does something useful. It's always unexpected and kind of funny.
It's like a little annoying, but also just a really cute.
Yeah, it's kind of like a handful. It's like you pick it up and it's like you
can't be mad at it.
This is great. Well, whatever sticker you want, email support@Adafruit and drop me an email, pt@Adafruit, and maybe we can help fund your next build, or if you want to document that anyway, let us know, because I think that it'd be nice if all of the IoT devices or cameras had personality to it. We'd probably treat them nicer.
Oh yeah, I think so. Thank you.
Hey, thanks for coming by.
Okay.
Last up.
Coding Pro. Coding Pro. Unmute your mic and show us your project.
Hello.
Hey.
Can you hear me?
Yep.
Okay, so I'm happy to be here. So this is my project. I made it. Is it inverted for you? Wrong.
Oh, it's a little feather.
Yeah, I got this in my Ada box. I forgot which one it was. And basically what it does is right now, why is it not working? Okay, there it goes. It shows the temperature, and I can do a quick screen share and show you. There it is. Okay. So can you see my screen now?
Not yet.
Yeah.
Okay, so this is where it's broadcasting to right now.
Excellent use of Adafruit IO. Good work.
And then I also am working on this other project. I coded an iPhone app, and I got a book about it and stuff. And it's called Birthdays. Can you see that?
Yeah.
Yeah.
I'm using the simulator right now, but I can allow it to send out notifications, and I can add a birthday, like, I don't know, random birthday, first name, just do a test, and it shows up here, and when, like, it will give me a notification when the birthday is happening, which is pretty cool.
Yeah, that's a good idea, because if you have to put it in your calendars, there's all sorts of other things you want to spend as birthdays.
Yeah. I mean, it does take a long time. This one's just the easy version. And let me stop. Okay.
All right. Well, you can email support@adafruit.com and get a sticker, and keep coming back and showing your projects. It's a really good AdaBox project, and when you release your app, if you email me, I need a birthday app, so I'll buy it and I'll give it a a good review if it works well.
And great mind, like I also have a humidity sensor right
Tony
here,
made a
feather-based.
humidity
So
sensor,
yeah, this one uses.
Friends.
Mine doesn't do Adafruit IO, so yours is better.
I have the I forgot your name. You're wearing the
Arc reactor, Tony. Yeah,
Tony.
Yeah.
Tony,
you're wearing the things. I did something for my a dance. I went to a middle school dance, and I put this strip behind my clothes, and in the middle of it, I went in my pocket, turned it on, and then it looked really cool.
Oh wow!
Everyone was like, "Who's the coolest kid?"
Nice.
All right, nice work.
Nice work, Coding Crew. Okay. All right. Well, that's our show.
Thanks, everybody.
Tell tonight, everyone. Thank you, Sophie. Thank you, Sophie's camera. Matt, Erin, Collin, Coding Pro, Azure, and Adam. We're here every single week. Thank you for making this the most fun 25 to 30 minutes that we have every single week.
Yeah.
Thanks to all the folks that we met in person and everyone who helped make Maker Faire great. We're going to do Ask an Engineer in just a couple of minutes. We'll see you all soon. Bye-bye,
I
everybody.
see you.